Recent studies have provided us with incredible glimpses of massive stars nearing their end. These celestial behemoths, many times larger than our own sun, are like cosmic time capsules. They offer us a preview of the dramatic transformations that await stars as they exhaust their nuclear fuel. These observations are critical for astronomers. They allow us to test and refine our models of stellar evolution. By studying these dying stars, we gain a deeper understanding of the processes that drive the life and death of stars across the universe. These observations also serve as a stark reminder. They remind us that even stars, those seemingly eternal points of light, have a finite lifespan. They too are subject to the relentless march of time and the laws of physics. The insights we glean from these dying giants provide valuable clues about the future of our own star, the Sun. While the Sun is not as massive as these stellar giants, it will undergo its own dramatic transformation in the distant future. To understand the fate of stars, we must delve into their very core. Stars are powered by nuclear fusion, a process where lighter elements are fused together to create heavier ones. This fusion releases an immense amount of energy, which is what makes stars shine. The primary fuel for stars is hydrogen. In the intense heat and pressure of a star's core, hydrogen atoms are forced together to form helium, releasing energy in the process. This is the process that powers our sun and most stars in the universe. However, the supply of hydrogen in a star's core is not infinite. Over billions of years, stars gradually exhaust their hydrogen fuel. As the hydrogen runs low, the core contracts and heats up even further. This increase in temperature and pressure eventually becomes high enough to ignite the fusion of helium. Helium fusion produces heavier elements like carbon and oxygen, releasing even more energy. This marks a new phase in a star's life. Giant stars are not born overnight. They are stars in a late stage of their evolution. These stellar giants are characterized by their enormous size and luminosity. They are significantly larger and brighter than their main sequence counterparts. The increased size of giant stars is directly related to the changes happening in their core. As the core runs low on hydrogen fuel and begins fusing helium, the outer layers of the star expand dramatically. This expansion is what gives giant stars their distinctive appearance. Their luminosity, or brightness, also increases significantly. This is because the helium fusion process releases even more energy than hydrogen fusion. This makes giant stars some of the most luminous objects in the night sky, easily visible from vast distances. Giant stars are relatively rare compared to main sequence stars like our Sun. This is because the giant phase is a relatively short-lived stage in a star's overall lifespan. Despite their rarity, giant stars play a crucial role in the evolution of galaxies. They are responsible for synthesizing many of the heavier elements that make up planets and even life itself. These elements are then dispersed into space, enriching the interstellar medium. Section 4. Our Sun's Destiny from Giant to Ghost. Our Sun, a yellow dwarf star, will not escape the fate that awaits all stars. In about 5 billion years, the Sun will have exhausted the hydrogen fuel in its core. As this happens, the core will contract and heat up, eventually igniting the fusion of helium. As the Sun transitions to helium burning, its outer layers will expand dramatically. The Sun will swell to become a red giant, engulfing the orbits of Mercury, Venus, and likely even Earth. This expansion will be a slow but relentless process, drastically altering the face of our solar system. As a red giant, the Sun will be a far more luminous and cooler star. Its surface temperature will drop, but its overall energy output will increase significantly. This will have catastrophic consequences for any remaining planets in the solar system. Eventually, after billions of years as a red giant, the Sun will exhaust its helium fuel as well. The outer layers will be expelled into space, forming a beautiful, glowing cloud of gas and dust known as a planetary nebula. At the center of this nebula will remain the Sun's core, now a small, dense object called a white dwarf. A white dwarf is the remnant of a star's core, no longer capable of sustaining nuclear fusion. It will slowly cool and fade over billions of years, eventually becoming a cold, dark black dwarf. Section 5. Earth's Uncertain Future. A Planetary Crisis. The Sun's transformation into a red giant will have dire consequences for Earth. As the Sun expands, the Earth's surface temperature will rise dramatically. Oceans will boil away, and the atmosphere will be stripped away by the intense solar wind. The once habitable planet will be transformed into a barren, scorched wasteland. Life as we know it will become impossible on Earth. The planet that nurtured life for billions of years will become a casualty of its own star's evolution. Faced with this existential threat, humanity's only hope for survival lies in finding a new home. We will need to become an interstellar species, capable of traveling beyond our solar system and establishing a presence on other habitable worlds. This will require technological advancements far beyond our current capabilities. We will need to develop new forms of propulsion, life support systems, and methods for terraforming or adapting to different planetary environments.